All right, so we took a little break from our quadratics when we looked at our complex and imaginary numbers and radicals and rational exponents, but we're back to quadratics for this unit. And if you'll remember, a quadratic equation is an equation that has something to the second power. So you'll notice all of these have x to the seconds in them. That is what makes them quadratics. And the only method we have right now for solving quadratics is to factor it. So remember, we use that zero product property where we would take a trinomial typically, but any expression, and put it in terms of multiplication to say, well, this factor could be equal to 0 or this factor could be equal to 0 to get our typically multiple answers. So quadratic formula is just another tool for solving quadratics. You could use it to solve all of the problems that you've solved before by factoring, but hopefully you'll see in a minute that it is going to be to your advantage to factor if you can. It is much shorter. So for me, the quadratic formula is only basically a backup if something is not factorable. So if it's factorable, great, we already have a method. If it's not factorable, then the quadratic formula is going to come into play, because it's this crazy formula that we're going to be substituting values in for that says our solution x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So there are some songs and things to memorize that formula if you are musically inclined. My method of memorization, to be honest, is just to write that formula on every single problem without numbers in it, like before I substitute, and I think you'll have it by the end of your assignment. So it does also need to be set equal to 0, just like your factoring. That's going to be our first step. And then a is going to be your coefficient for x to the second, b is your coefficient for x, and c is your constant number. If any of those are missing, we can use a 0, but x to the second, a, your x is your b, and your constant number is your c. So our solution x is going to equal negative b, I'm going to go ahead and put these numbers in, plus or minus the square root of b squared minus 4ac all over 2a. So you do not have to write every single step here. You can just do 5 to the second and write 25. You can do 2 times 3 and write 6. There is some flexibility there. So this is going to be 25, let's see, plus 4 times 3 times 1, so plus 12. Square root of 37. So sometimes the square roots we get are going to be simplifiable, and we'll need to do that. Sometimes there will be a GCF in the numerator that we will need to use to cancel with the denominator. But this is probably the most straightforward quadratic formula answer you're going to get. And technically it is 2 answers, right? We're used to seeing 2 answers most of the time when we solve quadratics. One of them is negative 5 plus the square root of 37 over 6. The other is negative 5 minus the square root of 37 over 6. And so those are we don't typically write them separately, but that plus or minus sign really is showing those 2 x values. So our answer is not nice, and it's just not nice because it wasn't factorable. So we're just going to get these kind of crazy answers when we use a quadratic formula. So let's look at the next one. The only thing we need to do is to set it equal to 0, and then we're good to go. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 64 minus 60, right? 5 times 4 times 3 is 60. So 64 minus 60 is 4. And we actually end up with a perfect square this time. So we can simplify that perfect square. And we get negative 8 plus or minus 2 over 10. But when we actually, we can do negative 8 plus 2. We can do negative 8 minus 2. So we're actually going to split these up into the 2 different cases. Negative 8 plus 2 over 10 and negative 8 minus 2 over 10. And we're actually ending up with some nicer solutions this time. So the first one, let's see, negative 6 over 10 and then negative 10 over 10. And we end up with relatively nice solutions. If that happens, it is because your original problem was factorable. So we can use factors of 5 and 3 to make that sum of the 8 in the middle. So this to me is why quadratic formula is really a backup for me. It would have been much faster if I had recognized that factorability in the beginning to get to negative 3/5 and negative 1 rather than going through this whole process. So I'm going to let you try the next one on your own after I get you started. I certainly don't want to deal with fractions within my fraction and fractions underneath my radical, but just as always, it is legitimate to multiply the left and right side by the same number. So the left side has 3 different terms that all need to be multiplied by 2, but that's going to give us 5x to the second, 8x, and whoops, not 6, 3. Those are numbers I would rather use in my quadratic formula. So my encouragement is either pause before, if I beat you, just pause so that you can have this as an opportunity to check yourself, or just go ahead and pause, and when you're finished, come back to the video to see how you're doing. There's one little aspect I still want to talk about at the end of this one, but see what you can do so far. All right, so I expect you got this far for sure. 8 plus or minus the square root of 124 over 10. So I said earlier, sometimes we're going to end up with radicals that can be simplified. The square root of 124 is one of those. Let's see, I recognize a 4 goes into it. That's great. So that's going to give us 2 times the square root of 31. And this is also one of those instances I referenced where the numerator has a GCF that's going to help us reduce with the denominator. So if I were to factor out a 2 of both of those terms in the numerator, now I've put it in terms of multiplication, and being in terms of multiplication is what's going to allow me to actually do that reducing. So I end up with x equals 4 plus or minus the square root of 31 over 5. All right, I'm going to get you started on this next one as well, encouraging you to see if you can write down the quadratic formula or substitute into it without referencing it, to just start seeing where you are as far as memorizing that. So let's go ahead and get it set equal to 0 together. X squared plus x plus 2 equals 0. And again, I would encourage you to pause. There's something a little bit different about this one as well, but you should at least be able to, I'm sure, get a portion of the way through. So see what you can do. All right, so I anticipate you got to a point where you had negative 1 plus or minus the square root of negative 7 over 2. We would have panicked if we saw a negative number under a square root. We know that squares are always positive, right? If I multiply something by itself, it should be a positive. But we just introduced imaginary numbers, which now allows us to deal with those negative square roots. So you will recall that the square root of negative 7 is just I times the square root of 7. And then typically, remember for complex numbers, we put them in the form a plus bi. So we do want to split this up where a, right, is just our real number portion, our negative 1 over 2, plus or minus our coefficient for the imaginary portion. There's a square root of 7 over 2. So that now puts us in the form a plus bi. So I don't know that we necessarily need to do a whole nother one together. However, you'll notice the next one, hopefully we're trained to remember that we have to talk about any sort of domain issues that x, because it's in the denominator, x cannot be 0 before we even get going with our solutions. So just in case at the end, if we got x equals 0, we would know to throw it out. So just as it's legal to multiply one side of an equation as long as you do the other, that's fine here as well. I'm going to multiply everything by x to the second to eliminate those fractions. So I'm going to get 2x to the second, 7x, and then that 4, I'm going to go ahead and use the inverse so that it's going to be set equal to 0. So now I've got my a, my b, and my c values. So quadratic formula, just another method for solving quadratics, equations with something to the second power. Ideally, if you can factor, it is easier, but this has to be there so that we can solve quadratics that aren't factorable.